So a few months ago now, I was approached to make a working prototype for a company who was hoping to put a small repeater into production, and their repeater was going to use 4 directional antennas, and they gave me these little boards here to actually build it around. And they really are a nice little board. They're very easy to set up as a repeater. You just have to choose which Wi-Fi network you actually want to repeat, and then once you've done that, the next screen asks you to put the password in for the Wi-Fi, and then bang, it's up and running. It's a little repeater. So I actually put it together. I don't know if it's ever going to be put into production. I do occasionally do little jobs like that where somebody wants an actual working prototype to take into the boardroom to sell, rather than something like a polystyrene block that's been sprayed to actually look like the finished repeater. But I did ask them where they actually got these little development boards from, and they couldn't tell me much apart from that they sourced them from China, and there's no actual markings on these to indicate who has actually made these, apart from the chip manufacturer. But they're a big chip manufacturer, and they make a lot of these chips for little ICs, and you often find their chips in routers and such like. So that was no help. So when I saw these, I did have the idea of actually upgrading my long range repeater video that I did some time ago now, using one of these, because they're so easy to actually set up. And again, you know, the board is actually laid out to how we actually want it. You've got these SMA connectors here, although I'm going to desolder these and solder directly on with some coax, so you don't have to remove any components. It's already laid out for you, so you can just come in there with the coax. And this actual USB port here is just for power, although you've got your 4 connections coming off it. The 2 middle ones, the data ones, don't actually connect to anything. It's just the positive and the negative. Now, I didn't want to jump straight in and do a upgraded version of the long range repeater if I couldn't actually source the parts or show links where you can buy the parts from that I was going to use in the long range repeater. And originally I used one of these little TP-Link routers here, but there were not, you know, you had to get in there and modify it with a soldering iron, and you know, it wasn't the best. The reason I chose this at the time because they were dirt cheap, and a lot cheaper than anything else in its class. And you know, it was sort of easy to set up, not as easy as setting up one of these though. So that's when I came across a seller on eBay, and he was selling these little repeaters here, and inside here we've got the exact same board that these are. Now, there's no manufacturer's name on these, so I can't find any other sellers that are selling them, but I'll put a link in the description to the guy that's selling these. He seems to have plenty of them. So I'm going to upgrade the long range repeater and base it off one of these little boards here. Now, how I'm actually going to construct this repeater, I've prepared my board so I can add some different connectors on here. So I've removed the 2 SMA connectors here and here. I've desoldered them away, and the easiest way to actually do this is to get a small Dremel tool and actually cut the bottom legs off here and here, and then flip it over, and then you can actually get in there with a soldering iron and easily desolder these 3 pins that are left there. If you try and do it without cutting those back legs off first, you will probably end up ripping the solder pads off, because these are really delicate. It's a cheap PCB and it's built down to a price. So the easiest way is to cut those 2 back legs off first and then desolder your 3 connections here and here. Now, I've also desoldered the USB connection here, so what you've got, you've only need your power, your positive and negative with this. So the 2 pins in the center, which are normally data plus and data minus, are not used at all. So I've actually desoldered this to get rid of it, and that way I can actually cut a round hole in my project box to have a bulkhead DC connector there, so it's a lot easier for me to actually do. Now if you think you can attempt to actually cut that rectangle out and have this sticking out at one end, you can buy a USB cable and do it that way, power it that way, but I think it's going to be much easier for me to just drill a round hole and use a DC bulkhead connector rather than the USB connector. So for this version then, what I thought I would do is make a much smaller cantenna Wi-Fi repeater than the previous one, and this is one that you could make, especially it's summertime in the UK now. If you wanted to get some extra signal strength into your garden, let's say, you could just put this on your dining room table and point it towards your garden, and this small cantenna will be powerful enough to actually flood your garden so you can actually get a good signal. So this Kenco coffee can actually you know, takes the cantenna all the way back to its origins of being a coffee can cantenna, let's say. And here I've got a project box that's going to house everything, and I've already got my two connectors here for, this is for the DC power that I was talking about, that I've replaced the USB with, so we'll have this directly soldered on to those two USB pads, and we can mount this into the end of the project box. And I've also got a short length of coax here that I've made up a little pigtail with a SMA bulkhead connector on the end, so I can actually drill a hole in the end of the project case here and have an omnidirectional antenna coming out the side. And to connect to the cantenna, what I'm going to do is just get another short piece of coax just like this and solder it directly to the driven element inside the can, and then have that coming down inside the project box and connecting to our little repeater. So I've drilled a hole for the driven element there, and the measurements from the back reflector to the hole are exactly the same as in all cantennas. So it wants to be 51.4 millimeters from this back reflector, and this can itself has a small recess just in here. So I've measured from the beginning of this rim here 51.4 millimeters. So I've got my project box here, and I've already drilled the holes for the DC power and the SMA connector here, so I can put a rubber duck omnidirectional dipole on the back. And as you can see, I've got some masking tape on the back here. Now I've got my hole in the can that I've already drilled for the driven element, and I want the coax to come up and through the bottom of this project box here. So because I want the project box to actually butt up against this rim here so it's nice and flat against the can, what I'm going to do is just put a little mark on the bottom of the box there, and I'm going to draw a straight line going up there and another straight line down the middle coming here, and where it crosses over, that's where I'm going to drill the hole for the coax for the driven element. Now before I actually start cutting this tubing down to size and soldering on the coax, etc., I want to actually use it as a guide to help me line up, because I want to drill two holes in the base of the actual project box and two holes in the can itself, because I want to attach it using these little nylon bolts here, these M3 size, so just to hold the project box against the can a lot more sturdier than epoxy or something like that. So if I put the tube in the project box and then through the can like that, and what I can do now, you see, is drill straight down through the project box and the can, two small holes, and then affix it with those bolts, and I know the holes are lined up correctly, so we won't have any mismatching. So I'm now going to solder this coax onto the driven element that goes up inside the can. Now I've stripped back some of the outer braid here. I've left about 25 millimeters of the inner core here that I'm going to use to actually solder on to some thicker copper wire at 18 SWG for the driven element. So this size here doesn't really matter so much, that you just want enough to actually wrap round that copper wire and then flood with solder. But I've trimmed away quite a lot of that outer braid that I've exposed there, and I've just left this small amount here. And I've got my piece of tubing, I've cut it down to 6mm, and what I'm going to actually do is I'm pushing that over that outer braid like so, and what I'm going to do now is flood some solder in there so we've got a nice connection to the outer braid to this actual metal tube in here. So it's the same technique if you were actually making your own dipole antenna, and just be careful with the solder, let it cool down in between, you don't want to melt this plastic dielectric here. So the solder's all flowed in there now, so what I'm going to do is get the Dremel tool and just smooth all this solder back so it's the same diameter as the tubing, so it'll fit up inside our can. So I've cut away the dielectric to expose the inner core now, and I've left about 2mm of that dielectric there just to act as an insulator between the driven element and the ground plane of this tubing here. And what I've got some 18 SWG copper wire here, and I've given it a good clean with some emery paper. I haven't measured it off to any particular length yet, and what I'm going to do is just wrap this inner core around the actual copper wire like that, and then I'm going to flood it with solder so it's actually attached now, so we've got that driven element in place. So it's actually soldered in place now. I'm going to cover it with some heat shrink tubing to actually protect it, but I've cut it down to 30.89mm, which is just shorter than the 31mm that most online calculators tell you to use, but those online calculators don't take into account such a small cantenna, and for something that's much smaller like this than the usual cantenna that I use, the wavelength of the driven elements just wants to be that tiny bit shorter as well. So I've got that tube soldered in place there, and I've just got the file just to smooth it off and level it out just so it still fits nice and flush with that project box. So while the paint's drying on that can, I'm now going to mount the little PCB board into the project box here. So what I'm actually going to do is widen these two holes slightly so we can actually use these M3 little nylon risers here. So they're going to be connected through there, and I'm also going to, once I've got the holes drilled, use those as a template to drill holes through the project box, so I can actually use this end of the thread here, and I'll just use it as a self tapper and trim off any excess that sticks through the other side of the project box. So I've drilled the two holes so I can actually mount it with the N3 risers here, and you don't have to worry too much, you're just drilling through ground plane, so it's not going to affect how the PCB works, for instance. But just on here on the underside you have to be careful here. There's a couple of little resistors quite close to the hole that you have to drill through. So what I'm going to do now is I'm going to use these two holes as a template to drill the holes so I can self-tap this end of the riser in place, so it'll be fixed quite firmly inside the project box. So the project box is now held in place with the two supporting M3 screws and nuts there. Now what I'm going to do now is solder on the power wires here so we can actually power this board, and we've got the positive needs to be soldered onto this pin here and the negative to this pin here. So I'm going to keep these the length that they are because I want them to actually loop round and back on themselves, and I'm soldering them like in this position here, so that way I can actually just flip the board over and I can mount it directly onto its M3 mounts here. And I've chosen to mount it that way up because it's going to be much easier for me to actually solder the coax that way, and also the little reset button here is exposed, so it's going to be easy for you to actually get in there, pop the lid off the project box and get in there and press that for 3 seconds if you ever want to reset your repeater. So the two coax are soldered in place now, and what you want to do, you want to lay the coax pretty much where it wants to lay. If you try to force it, especially into a tighter bend, then what you're going to end up doing is putting a lot of strain on these solder pads. So here what I've done, I've looped this one round here, soldered it in there, and the same with this one. Now if I try to solder this coax onto these solder pads here, it will be a really tight loop, and it will put a lot of strain on the solder pads. So try and lay it where it actually wants to lay without forcing it into position too much. Now, depending on which one of these you're going to make, the longer range repeater or the repeater that I've just made in this video, where you actually tap out for the tripod mount here will depend on which one you make with regards to its center of gravity. So on the smaller one, you need to tap out a hole in the middle of the project box, and on the longer range one, it's quite near the edge of the project box, just so it sits more stable on the tripod itself. Now, what I've actually done as well with the longer range one is I've got some epoxy putty, and I've just put a line down in between the project box and the can itself, just to add a little bit more stability. When it sets quite hard. You could probably do this with some silicone sealant if you get in there with the tube and actually just put a line down there. But I'm going to do the same thing with the shorter range one, just a thin line of epoxy putty. And to block up the end, what I've done is I've cut a circle out of some cork matting, which is 2mm thick, and I've just epoxied it on the end, so I'll put some black paint on that now. So to test this repeater out, what I've done, I'm in my workshop at the moment, which is a pretty poor signal in here normally because of you know, it's got a big metal garage door, etc., and a couple of brick walls between me and where my router in the home is positioned. So, but what I've also done, because the router that I use in my house for everybody to connect to, it's been modified. I've actually put on the router that I originally got from BT, which is a Hub 4, and it is totally unmodified. It's got no external antennas or anything like that, so it's as is, broadcasting now into my workshop, and it's getting well, it's creeping up to the 60% mark. You can actually connect with this, and you can browse the internet. You can already see it's already dropped out there once. So what I'm going to do is pause this, and then I'm going to go into the house, and I'm going to switch on the repeater, come back and see what signal we actually get from it then. So I've come back, I've started the screen capture again, and as you can see, it's well up there into the 90s, probably around 94%, so I'm quite happy with that. So, and it's a solid signal as well, there's no drops in there. So that just shows you how well the repeater will actually work, and that's the smaller repeater that I've got plugged in, not the longer range one. So hopefully you can see from this test what kind of performance you can get to actually boost the signal to somewhere specific in your house or in your garden. So here are the two repeaters, the smaller one at the front and the longer range one at the back. And if you wanted to actually make the longer range one, you just use the same methods that I've shown in the video making the smaller one, but you just have to get one of these toilet brush holders and make it out of that. And of course, if you do the same hack that I've done to change the power supply from the USB to the little DC jack there, you're going to need to make yourself a cable up like this one. Just really simple. I've just got a normal USB cable and cut the one end off, and mounted a little DC jack at the end of there. Just solder on the red wire is the positive and the black wire is the negative. So again, I hope you enjoyed that video and you have a go at making one of these yourself. Just drop some comments below and tell us how you've actually got on and whether you've actually tested it and gives you significant range. As for actually the cost of making these, there's no real difference, no cost saving making the smaller one. The costs are the same. It's just that if you've got a smaller garden like I have, then using the longer range one is a bit of an overkill. So the shorter range one has a much wider beam width, so you'll get more out of it in a smaller garden, let's say. And another thing to note about these as well, the two antennas, they don't differentiate between let's say transmit and receive. They both transmit and receive. It's just that one of them now is a cantenna, so that's a much more directional antenna, so really it's only going to work in one direction. But that isn't necessarily a bad thing, because you could also take one of these away with you to, let's say, a hotel, and they're only offering Wi-Fi in the lobby, let's say, and they're charging extra to have Wi-Fi directly in your room. You could actually mount one of these on your balcony and flip it around, so you're using the cantenna to actually get the signal from the front of the hotel, and the omnidirectional you're using to actually put that signal in your hotel room. So you can flip it around if you like, instead of using the cantenna to beam a signal say into a garden or at a distance so you can pick up a Wi-Fi connection. This way you're actually using it as a kind of more as a receiver, so actually getting your Wi-Fi signal in there and then beaming it out to your room with the omnidirectional antenna. So you know, it can be used both ways, so it's not necessarily a bad thing when you know, you've got the two antennas that are still receiving and transmitting. So again, I hope you enjoyed that video, and if you did, please give it a thumbs up. Drop a comment below, especially if you build one of these. Let us know how you get on. Any questions, drop them below and I'll do my best to answer them. These will also be in the shop soon. I'm not sure about the price. I'm going to have to sit down and work that out. Obviously this the cost of the actual circuit board, etc., to take into consideration. So hopefully you enjoyed it, and hopefully you'll join me on the next one.